Welcome back, Chemistry Theory. This is part 2 of the 15.2 booklet. So earlier we looked at solution concentration and how to figure out molar concentration. This one will look at preparing standard solutions and also diluting solutions. So the first step here, when preparing a molar solution, this is outlined on page 466, but I summarize it here. So just what we did earlier there, use C equals N over V to determine how much solute is needed. So first of all, that'll help us figure out moles if we know the volume that we need and the concentration. And then once we know the moles, use the molar mass to figure out mass in grams, because we don't have balances that measure in units of moles. We need it to be in grams. Okay, and then next, once we have that solute measured out, we place it into a volumetric flask. Ideally, that flask should be equal to the volume that we want. So for example, if we're making a 250 ml solution, we want a 250 ml flask. And then top up with water, with distilled water, to the appropriate mark. B, which one thing you have to be careful with. So if you look here, here's a volumetric flask. If we fill it up with the water first, let's say we wanted to make 500 milliliters, if we fill it up with 500 mils first, then put the solute, technically we'll have more solution than we require. Because remember, solution is solute plus solvent. So be sure to put the solute in first, then the water up to the appropriate mark that's required. Okay, and just the next part here, I just allude to, there's examples in the textbook, but hey, we'll be going through a few of them here anyway. Okay, so here, how would you prepare the following solutions? One thing that I've been meaning to change with this question is changing this, because 64.3 milliliters, you wouldn't likely want to make that exact amount. Usually you want installments of 100, so a 250 ml solution, 500, but for all intent and purpose, we'll assume that we have a 64.3 milliliter flask, just to make it easier. And we want the concentration to be 0.0238 molar potassium hydroxide. So of course, if we look back here, the steps, we're going to figure out the mathematics of it, and then the verbal statements here outlining what we need to do with that. So if we look here, N is equal to C over V. So our concentration, 0.238 moles per liter, multiplied by, I'll move the decimal 3 places to the left, decimal 0.643 liters. So that works out to be decimal 0.0153 moles. And of course, we don't have a mole balance, so we have to find out the molar mass of potassium hydroxide. 1K plus 1O plus 1H, 56.1 grams per mole. And then just what we did back in Unit 1, convert that to grams. So decimal 0.0153 grams multiplied by the molar mass, decimal 858 grams. Okay, so we've done the mathematical part. Final part is to say what you do with it now. So we take that decimal 0.585 grams of potassium hydroxide, place it in a 64.3 milliliter volumetric flask, and then top up with water to the 64.3 mil mark. Okay, so for these questions you have to show the calculations plus the verbal statements outlining what to do. Okay, then I'll let you do the next one. Pause the video and see if you can do the next one, then we'll look and see how you did. Okay, if you had a chance to do that, of course we have the concentration is 0.225 moles per liter. The volume is 750 mils, or 0.7500 liters. So solving for number of moles, you should have got 0.16875 moles. Then of course we have to change that to grams, so multiplied by the molar mass. And the molar mass of ammonium hydroxide here should be 35 grams per moles. So that works out to be 5.91 Gs. So hopefully you got that correct when you tried it yourself. And then just the verbal statements. Mass out 5.91 grams of ammonium hydroxide. Place it in a 750 ml volumetric flask. Then top up with water to the 750 ml mark. Okay? So there you have it. That's how you prepare a standard solution. And you will be, in fact, doing that right after this assignment. So now with the last part, we look at dilutions. Now, when you dilute something, whether it's like an iced tea drink or something like that, you still have the same amount of solute after dilute, but it's the amount of solvent that changes when you dilute something. Okay, so you always have the same amount of solute, different solvent though. So that kind of helps us figure out what the relationship is here between a regular solution and what it is after you dilute it. So if moles of solute before equals moles of solute after, we can say N1 equals N2, or C1V1 equals C2V2. So all I'm doing here is just using the molar concentration equation here. N before equals N after, therefore CV before equals CV after. And I just use a little subscript 1 and a little subscript 2 to distinguish between the two. So your original solution and your diluted solution. And a little note I make here is that you can have V1 and V2 be present in milliliters, but just be aware that if this is in milliliters, this has to be in milliliters. Okay, so if we look at these, people usually tend to have a little bit of difficulty just interpreting the question here. If you think of finding the before and the after, you'll be one step ahead of everyone else. So the question here says, how many milliliters of a 2.55 molar NaOH solution is needed to make 125 mils of a 0.75 molar solution? So needed to make implies that this is the solution you're making. You're diluting it into this. You're starting out with this, and then you're making this. So, and also another indicator here is that your C1 is going to be bigger than your C2 because, once again, it's diluted. C2 is always smaller than C1. Okay, so I've inserted all of the variables here. How many milliliters of this solution? So we're actually looking for V1 here. How many milliliters of my original solution do I need to make 125 mils of a 0.75 molar solution? So that's the tricky part with these questions, just figuring out what you need to find out, distinguishing the original solution from the diluted one. So C1 V1 equals C2 V2. We're looking for V1. It's V1 multiplied by C1, so to undo multiply I have to divide. So I have this kind of messy here. So divide each side by C1 and my equation becomes this. V1 equals C2 V2 over C1. And then I substitute all my variables in. Molar cancels and I'm going to be left with milliliters. So that works out to be 37 mils of my original solution that I need. Okay? I'm going to get you to read the next question and see if you can fill in the V1, C1, the V2, and the C2. So pause the video now and see if you can do that. Okay, if you had the opportunity to do that, how many mils of a 0.400 molar HBr solution can be made? So you're making this from this. So the question's kind of flipped around to how it was with the previous one. Our original volume and our original concentration, and our new concentration and our new volume. So, and again, C1 is bigger than C2. That's another indication. So there we go. We have C1 is 8 and V1 is 50. C2 is 0.4 and we're looking for V2. So C1 V1 equals C2 V2. We're looking for V2. So divide each side by C2 and there's our equation. And it works out to be 1,000 milliliters, which is interesting. 3 sig figs everywhere, so we have to have 3 sig figs here. So to show that we keep the 1, the 0, and the 0, we can put a line over this 0. Or even better, write it in scientific notation. Okay, so there we have it, dilutions. And the last part here, just simply looking at the vocab that we have. So dilute solution versus concentrated. Solution has a lower concentration than some original solution, or we can say it has less dissolved solute than a concentrated solution, which has more solute in a given volume. And here in the diagram, I just show a larger amount there. Okay, and then lastly here we have molarity, which is concentration expressed in terms of moles of solute per liter of solution. So this is a key point to look at here. And of course, we have these side conversions here. We know V has to be in liters, N is in moles, but sometimes we need to convert it into mass, etc. Okay, so there we have it. So the second part dealt with looking at preparing standard solutions and also dilutions. The next video we'll look at an activity in which you will actually make a standard solution. Okay, we'll see you next time.